today's video, we look at question 20 of the higher tier Edexcel maths paper, June 2019, which is a combination of knowledge in vectors, ratios, as well as an expectation of knowing how and when to set up algebraic expressions to model a problem, as well as an understanding of coefficients in vectors. So let's just read through the whole question first of all to understand what the examiner is looking for and how earlier answers in that question may be able to give us a clue how to answer later points of this question. So we are given a quadrilateral CDEF with vector points of CD, DE, FC with the associated vectors, and we're being asked to express or undefine vector FE in terms of A and B and give the answer in its simplest form. After that, we're then told that M is the midpoint or halfway between line DE, and X is the midpoint, and X is a point somewhere along the line FM, in that it's split up between Fx to Xm in the ratio of n to 1, and we're also told that there's a line which hasn't been drawn in. CXE is a straight line, and we're asked to work out the value of n. So before we go about answering this question, let's look at the general framework that's set up to help solve vector ratio type questions, and then move on to how we use this particular framework to solve this particular problem. So step one, we have to label the given vectors. So identify your starting and end point of the vector, such as A to B, and label that as AB. Assign the single letter vector, for example, A to the line AB, based on the given information. And step two is then determine the key points on lines of interest. For example, a dividing line or segment line, and identify maybe the midpoint or the ratio or fraction that's meant to be found. Step three, set up expressions for the required vectors. So express the unknown vectors in terms of known ones, such as A, B, and C. And in step four, we're asked to set up an expression for key points and ratios. And this is where we introduce our own variables, such as X and Y, where appropriate, to express key points along the line segment. Remember, X and Y are not vectors, as they are with A and B, but rather as multipliers or simply numbers such as a half or 3 or 4. And step 5 is to consider algebraic substitution. So basically you're expected to solve the expression that you set up in step 4. So consider how the variables X and Y, etc. can be substituted back into your expressions to solve the answer. Now, a couple of key points to remember when dealing with vectors. If you've got two separate vectors, such as A and B, and they're equal, and they are equal if they have the same magnitude and direction. And the other key point with vectors is different roots to a resultant vector, such as AB, will always be equal. So let's go about answering question 20a, where we are asked to express the vector F to E in terms of A or B. So using our framework, step 1 is labeling the given vectors. So we've got vector C to D is notated by vector A, vector D to E is notated by vector B, and F to C from here to here is notated by A minus B. And we've got to express the vector F to E. So to get from F to E, we can do it by going probably a couple of ways, but let's go from F to C, because we are already being given those vectors, C to D and D to E. So those vectors that are being given to us are F to C is, I should put in directional vectors as well. F to C is A minus B plus A plus B, which gives us A plus A is 2A, and the minus B plus B because it's 0. So our vector f to e is notated by 2a. Let's label that up here, 2a. Second part of the question, and using our framework as well, as it talks about identifying key points and ratios. So the key point here is we're told that vector m is the point along line DE, and it's a midpoint. So it's halfway through. So this will tell us that actually D to M is half of B, and M to E is also half of B. So we could just take that as that if we want to. A little bit confusing, so let's probably take that out for the time being. We're also told that X is the point along the line F to M, such a distance from F to X and X to M is notated by the ratio n to 1, and we're asked to calculate the value of n. We're also told that the line XCE is a straight line, which we haven't got in at the moment, so we need to draw that in. So using our step 2 guide, let's fill those points in. So let's put in the straight line first of all. So part 2 of the question asks us to work out the value of n. And let's get that out of the way. Whoops. So part 2 of the question asks us to work out the value of n. We know that n sits somewhere along the line fm. So let's make a vector expression for fm to start with. So fm is equal to fe plus the vector e to m. Now we know that d to e, the vector d to e is denoted by b, and we know that m is a midway point, so that means it's halfway, so these points are half of b. So fe is equal to 2a, and we're going in a negative direction for e to m. That gives us negative a half b for fm. Now, we need to create some type of expression for indicating that n exists somewhere along this line. So let's think about it in terms of how we split up a ratio line. So I'm going to just draw out a line here separately. Let's just think about it from this point of view. So think about this as being the f point, m point, that's our fm line, and x sits somewhere along there. And we are told from a ratio point of view that this is n to 1. We could work this out in terms of, we could fraction. Let's just get this as a fraction, where the total length of this line is n plus 1. So f to x is n over n plus 1 as a fraction, and x to m is 1 over n plus 1. So we have an expression that tells us that f to x is equal to some fraction n over n plus 1 multiplied by the full length of the line fm, vector fm. So that's one way of creating an expression, and that's part of our step work 4 in our framework. We could also, just to simplify things, say f of fx is equal to some multiple or some fraction. I'm going to use a small x to denote that multiple or fraction multiplied by fm. when you can think of x as actually equal to n over n plus 1. Now, these are two key points that are worth bearing in mind. So let's just kind of highlight these in red, that one there, and we're going to highlight this one as well, because these are important expressions that we're going to have to think about using at some point in our calculation. We can now use, we already know what fm is from up here, we've got 2a minus a half b. We could then say that fx is equal to n over n plus 1 bracket 2a minus a half b, or we could say it's equal to fx is equal to small x 2a minus a half b. The challenge we've got is that we don't, our line fx doesn't actually allow us to get any more information for either our n, or if we simplify it, for our x, which means that we need to find another expression for fx that might allow us to think about the vectors in a slightly different way. So what we're going to do is let's create another expression for fx, alternative expression for fx. Remember, we're doing it on fx because we're wanting to look for the value n along this line. So if we say fx is equal to, let's see, we go from f to e, or we could go f to c and c to x. Let's do f to c, because we've got a value there, f to c plus c to x. Now, we don't have a value for c to x. Could use a similar approach as we did earlier on calculating an fx line. So we could say c to x is equal to some multiple, let's call it y, of the line CE. We also know that CE, C to E, is equal to C to E is equal to C to D and D to E. So we could do C to D plus D to E, which gives us A plus B. So Cx now is equal to Y plus A plus B. Now how does that help us? Well, let's see what it creates in terms of an fx line. So fx now, our new alternative fx is equal to fc, which is a plus a minus b, plus c to x, which is y bracket a plus b, the cx line here. So we've now got two expressions for fx. We've got one up here and one here. So let's just try and equate those and see what we get. Let's write it out more clearly. So fx is equal to this equation here, x to a minus a half b. That's equation 1, and equation 2, fx is equal to a minus b plus y a plus b. Okay. Now these two vectors should be equal. And for vectors to be equal, the A's and B values must be equal. We've also got x's and y's here. You need to remember that the x and y values are fractions or multiples. So they are not a and b's. They are not vectors themselves, they're multipliers of those vectors. So let's try and equate these and see what we get here. We get a so given that our x's and y's are multipliers, let's just expand our brackets out. We've got 2ax minus half bx is equal to a minus b plus ay plus by. Now the a's and the b's must equal one another. So this is the next step in thinking for this type of question, is equating. So we need to equate the a and b coefficients. These are just the numbers that sit in front of the a's or the b's. So if we equate, let's start with a. That's a coefficient of a, we get 2x there. There's no a's on the other, no other a's on the left hand side, is equal to, we've got a 1a there, and we've got a y there, and there's no other a's. Let's do a coefficients of b, and we've got a negative on the left hand side, we've got a negative half x equals negative 1 plus a y. Let's see if we can solve. So we've got this either as, so we've got this either as a, so we can solve this either through substitution, we can solve x and y through substitution, or simultaneous equations, whichever one you feel more comfortable with. Let's just go with the substitution. That looks that much easier. So we're going to call this equation 3, and this is equation 4. So looking at equation 3 and rearranging, we've got 2x is equal to 1 plus y. Y is therefore equal to 2x minus 1. If we sub 3 into 4, we get a negative x, half x is equal to negative 1 plus 2x minus 1. If we rearrange, let's multiply by 2 on both sides just to get rid of that half. So that leaves us with a negative x is equal to negative 2 plus 4x minus 2 here. That gives us negative x is equal to negative 4 plus 4x. We rearrange this. Let's get our x's on the right hand side and our numbers on the left hand side. So that gives me 4 is equal to 5x. Therefore x is equal to 4 divided by 5. Where does that get us? Well, actually the x value we were calculating is really along this fx here part. So that therefore means that, let's just draw this out again so it's a little bit clearer what we're trying to do. F, X and M, splitting the ratios 1 to n. This is actually split into 4/5, and this naturally has to be 1/5. Therefore, n has to be equal to 4. But if that doesn't feel comfortable to you, we could just equate our x equals 4/5 to this equation here. So we've got n/n, or the other solution, if you're happier with seeing it this way, is n/1 is equal to 4/5. We just simply cross multiply, we get 5n is equal to 4n plus 1. 5n is equal to 4n plus 1. N gives us n is equal to 4. So we can still get the same answer. So your answer is n is equal to 4. Let's have a quick review of the summary of the steps we took to solve this problem part B in part B. So we labelled up all the vectors. Second point, what we were aiming to achieve, the question was asking us to calculate the value of n that sits along the line fx. So our aim was to set up an algebraic expression to calculate fx. The problem was that that expression didn't lead us to an easy way of calculating n or the x value. So we had to set up a second alternative algebraic expression for fx. And then we had to look at equating the two expressions for fx together. And by equating them, we had to match the a and b coefficients, not the x and y variables that we added in, because they were scale factors. We then also had to consider using either simultaneous equations or substitution to solve the value of x. It's important that you recognize that the x value or the y value we introduced was a multiplier or a scale factor or fraction, whichever way you'll feel more comfortable to understand it, that solves the value of n. Alternatively, we could equate the value of x, which we calculated, to the ratio fraction that we built out and generated earlier on in the question. So if you look at the supplementary point, and it's something that it's important that you understand how you calculate fractions from ratios, be comfortable from the fact that from a ratio we can calculate a fraction, and we can break up this lumber line where we found that the x value is equal to n over n plus 1. And a second point, this isn't part of the question, but it gives you some kind of sense of confidence that what we're doing was taking the correct approach, was that looking at validating the coefficients for a and b, which are the a and b are the vectors or vectors for the question, where we have the vector fx is equal to this expression. By substituting x into it, which is 4/5, we end up with our final value for what that fx factor looks like. Alternatively, we can calculate the y value in the equation 3 and substitute that into the alternative fx expression we calculated, and that also generates the same fx vector, therefore indicating that both vectors are equal in calculations. This was an extremely challenging question, but I think it's useful that you understand the approach that is taken for trying to solve this type of ratio question where two expressions, critically two algebraic expressions, are actually required to help generate the answer, as well as understanding that you need to match or equate the a and b coefficients from the two fx expressions.